Betul.
Sasa muda saya Kristen.
Jam hiyo tunawasikia. Ile jam hiyo tunawasikia sana. Sisi tuzi
Bisa nimeleta Julius tu. Ngoja tuone.
Ako kama kila kitu.
Nehemia.
Hello, everyone. Good afternoon. Thank you for joining us.
Session. And we have two digital officer with us today. Without further ado, I will give started my one to the floor. On presentation. Welcome everyone. Good morning, good evening, users. And welcome to this. As environmental science becomes actually more and more of one science, especially now with AI already. So you're not going to hear from me, so I want to leave the stage as soon as possible to our experts. Just a quick introduction on why we're here, who is going to be joining us both in the room and online. So, with us in person in Nairobi, and Nairobi is you. And we have a number of fantastic experts. We have Sonia Rafi, the research director at Stockholm Environment. We have Garcia, sustainability and policies at ICO, International Organization. And then from the government trust, and then also the Ministry of Development Transition Biodiversity Forest. And not we have science and studies are like replacing of data in science housing.
Like don't forget.
Many of you will know how hard it is to combine environmental data from resources. Then we were moving to combine data sets from the different ways. There are research, hundreds of different standards that make it really difficult to exchange data. Sometimes even within the same environment that don't make any kind of possibility. So this is what we're going to discuss today with our experts. The idea is not something rather to be able to hear from experts from other regions who have experience with data standardization and with data interoperability. And this is why we have at UNEP, we have some of the biggest standards and data organizations in the world to give us their expertise and their experience. So with that, let me hand back over to Polina and wish you success.
Thank you, Sally, and thank you for this introduction. And I hope you can hear me well. It sounds far away. I'm not sure if it's notable sound. Okay, thank you, because it looks like voice line cannot hear us. But let me start with the first speaker that you have, and the first speaker of mine is Israelia Garcia Naga from ISO. Can you hear us?
Hello, good morning, good afternoon. I'm having really a bit of struggle with the sound. I can almost not hear you. I hope you can hear me.
Okay.
You can maybe give me a sign.
But I cannot hear you. So if you can make sure that the sound is on.
Can you hear me?
It looks like the
Hello, can you hear me?
Thank you, Simon. So now we just need to make sure that the audience can hear you also. It's good to know that you can hear
Okay,
us.
on my side, I can hear you a bit better now. Can you hear me? Hear me? On tip. Other room's gone silent.
Come in.
Try now.
Can you hear me?
It's coming from my laptop.
Yeah, we can hear it.
Yeah.
Yes, not on the
Yeah.
system.
Do it from here. On my...
If we can fix it, maybe now.
Let's see, otherwise we could start and then with you, because you are in the room and can be heard, and then we will move on to the line speakers.
Can you hear me or not?
One chance to fix it.
Would you prefer to start from the room? I could hear you now, but I don't know whether you are hearing me.
Oh, where is the... Okay. Try to speak again.
Can you hear me? The last person that just talked, I could hear her very well. But
No. Where
I
is the
started sharing
microphone?
my screen.
Yeah. It's not really a good solution.
Good solution, but it's temporary till it's fixed.
But those online can hear me, right?
Yeah. Okay. Better?
Can the room hear me? No, it doesn't look like. The room, if you want. Try later.
Earlier? Yeah. Can you try speaking earlier? Try once again.
It's muted. You are muted. Yeah.
I hear very low. I don't know.
Oh, it's her connection.
Can you hear? Equal.
Lina, can you say something?
I don't know. This is
Also for that, maybe we can find out the speaker just to make sure that it works with someone else.
If you hear me.
Yeah, someone got something because there is a
Very
Now it's what?
there is a way to can loop the sound inside.
Can I see say something? Yeah.
I think it's working now, but the link maybe is
Changed.
so we can hear. But,
See, using Which one is this one you're taking out?
No, this is
This
the
out. This one is not.
It's not the one.
This one should be.
We connect to speakers
I need to use
to get
This
the
one.
audio from your
Yes, I'll-
speakers to the sound system. It's ready.
to this, then to this, then to
Okay.
But you listen to the audio.
I just
the video and the
even video.
maybe we can try this.
It's free to control.
Yes, your speaker. Try here to change your speaker to the.
But they can
mic.
use the mic
Yeah.
if they use the mic.
Nairobi and the Balian of the area. And if we go to the next slide, or you need the international. We have 194 member states, but we have reduced the results. There were almost 1,000 members of academia, NGOs, members, our members in this country, all these technical aspects in that. I will tell you more later. In the last 20th century conference, South Strategic Plan, the United States gave us a mandate from the University of the sustainability. One, the important of the consumer trade. Move to the next slide. Member states gave us other mandates as well to work on the environment and digital, to make the digital green, and to support the green in digital solutions. And here, for example, I don't it's very important to explain what we are doing, what is the mandate for each of the resolution I mentioned. What is important is really that there is a focus of membership, and they gave us a mandate. What is the mandate? Because who gave us it? This is important, because of course you have a mandate to work on environment, including digital. You have a mandate to work on digital, your body. But the national level, there are different needs. Last participating in our families are the minister of digital, ICT or digital or AI, doesn't matter. That's what's mandate was to work the national level.
What is it?
And the one we
Una conectate. Magia con
we are co-chair and champions 200 companies to report their data. In a way, pushed us, first of all, to work internally because we have a federal government, which is difficult to manage, to work internally, more consistent, to work together, and then to involve externally more and more partners to work on digital for the environment and environmental and the digital being more greener. And that's why we started in 23 what we call digital action. It's an initiative where we partner with other members, us like 40 companies in another time. And we presented, once more in okay. And we presented the first time a common program in COP28. In COP29, it was a big success because we had in our roundtable 62 minister, deputy minister, chief executive of companies, and chief of NGOs signed and assuming a declaration, between action declaration, when this was enforced and approved, and was by 80 states and more than around 1,800 companies. And here it was highlighted the importance of the consistency between the digital and environment. And you can see that next slide, please. They are sustainable. Means what and the first report was an intermediary report The methods of we measure to identify the gaps, to identify the gaps on the data, to identify the gaps, what is measured, what is not measured on the whole process, to identify the method of transparent of the liable system. And I will invite you on the publisher. Identify entities. For example, there are not really measuring data, considering data files and different things. The data in fact can be estimated if you wrong. We are not measuring our data on the process. It is not that we are data centering one, just one is. There are much more other. We are not measuring, for example, water consumption for the data. We are just estimating. We are not measuring the fact that they are from other expecting them to be not starting. These are some of the findings. And this is not very dry. What is needed? We want to start with something. With our colleagues from Africa was to organize this year hackathon. The hackathon for SMEs to see if someone can identify how we can measure data, power data and water data for data. And we announced the winner in COP13 Berlin. It was a SME called that development applications and AI. Yeah, and it's really outstanding. I think because okay, all this work we are doing with practice in our members. In fact, I'm guiding the work we are doing in the we are working with the standards, working with strategies where there's big streams that's in the community program. And developing because standards, related to environment, because that's good fun. Then it has a mandate for environment. You can see on the screen, you can see, if not, you will see better. But what I can tell you is that one of the focuses circular waste management and ICT related to environmental energy efficiency, clean energy, sustainable digital and climate action. And based on that, they are inviting subgroups in question how we go there. And they are developing standards. If we move to the next slides. Here, they split the whole process of impact that they are in, the life cycle that they are in. And you can see here, and they split it in different parts. And they are focused on each part, for each part, developing standard and everything. The next slide, but let's keep it like so it should be now. I'll give you some examples of that. And on the other hand, they try to identify because which are the environmental factors in the AI impact. And they divide between energy consumption, algorithm efficiency, algorithm optimization, sustainable energy, and data management. And for this, each vertical, they try to advance developing the standard. Let's move to the next one. Here, because what I like to explain, they provide standards. And you can see all the standards at the product level, site level, network level, and additional resources in the system. And they try to harmonize metrics for energy efficiency and so on. Let's make this look at the environmental spot. I have 2 more slides. Let's go fast. Well, this is important. But after what the study group did with the impact analyzing what are the gaps In fact, they tried to develop based on that, and together with LCB, European standardization body, a guideline for assessing the environmental impact of the reactor. They are now, they are working on that, and let's move to the next, and I'll not go because here you can see what kind of components that have the whole guidelines, what you have in individual examples. But the important thing I want to say is that I cannot say, for example, these are the best standards, we need to follow this. What is important is we develop all together different methodologies, different standards. We need to communicate, and our standardization part is in an alliance with the ISO and IEC. And now we're starting to work together on these matters with the NC. And I think we need to learn from each other. It's not that we can do the competition, because we can't do innovation. And I think we have and I think what is important, what we need to keep in mind is we want to have a consistent approach to a problem like poison alarm. We need to work together. Otherwise, each of us will say that ours is the best, but in fact, at the end, we will not be successful. This, I think I have just one more slide. Yeah, this is the fact that we participate in COP30 in Berlin, and we promote this. Thank you very much. Sorry for being rude.
Ekelea kwa speaker. Hey. She's
Thank you so much. Thank you so much for sharing what ITU is working on and on the environmental standards, and thank you for emphasizing the fact that we should all work together collaboratively, because that's one of the also messages of this event. And I can see very encouraging messages that the speakers online can hear us better. So I hope we can also hear speakers online now. And I would like to hand over back to Naomi. And hopefully, let's first maybe test that we can hear you. Now, can you say something?
Can you hear me now?
Oh, yes, actually, we do.
I hear you until now, but
yeah,
can you hear me?
Hear you.
Let's try.
Yeah, let's try. Well, and I would do over to you to share your work on data standards related to environmental data in ISO. Over to you.
Thank you so much, Paulina, and thank you to everyone for keeping up with technology issues that we all face today. It's a pleasure to speak to you today, connecting from Geneva. What I wanted to share with you today is a simple but a crucial idea. So if we want environmental governance to be truly credible policies that are generally efficient and AI that actually helps rather than harms the planet, we must get data standards right. And we must ensure that those standards are actually aligned internationally. And to ensure to get to that alignment, what we need is multi-stakeholder international standards platform. And that's actually what ISO can offer. So, but what is ISO? ISO is the International Organization for Standardization. Is a global network of national standards body, one body per country, officially recognized by its government as the representative of that country in the international standards network or platform. We are an independent non-governmental organizations, although some of our members may be part of government. And our role is straightforward. We provide a platform for countries and stakeholders to develop international standards by consensus for use around the world. We bring together 173 national members, national standards bodies from all regions, and we publish tens of thousands of standards. Our portfolio today is more than 25,000 standards that range from environmental management to water to soil and management systems, geographical information, and others. Through our members, we bring together tens of thousands of experts into more than 250 technical committees, and those experts represent a variety of stakeholders, being government, being the UN system, being science representatives, academia, industry, or civil society, to develop those international standards that will afterwards actually underpin laws, policies, platforms, organizational operations, and also contracts. But then start with a reality that many of you know very, very well. Today, the default is fragmentation. We have environmental data fragmentation. And why is so? Because we have many actors, environmental ministries, meteorological agencies, statistical offices, organizations, NGOs, often using different systems, vocabularies, mandates, etc. We have also a number of multiple platforms, portals at national, regional, global levels, and each one with its specific use. And then at the same time, we have more and more AI tools, data analysis services that are being added, but many of them are actually privately owned. So given that complexity, that fragmentation, what is the consequence? The consequence is that environmental governance makes that fragmentation makes difficult environmental governance. Many different people taking decisions, often using only partial information. And today we know that decision making requires a general overview. Many topics are today cross-connected and interlinked: climate, biodiversity, pollution, land, people. All these cannot be treated separately. However, fragmentations makes that decisions are made by having only a partial picture, with institutions that have different numbers, different assumptions, again, and this makes governance, environmental governance, very complex. Fragmentation has also an impact on policy efficiency. It creates duplication and delays. Teams, policymakers spend a lot of time trying to harmonize formats, definitions, instead of looking at the implementation and at the solutions. And then thirdly, fragmentation makes that AI platforms and services might be untrusted and decrease their performance. The different AI systems using different data produce results that might be difficult to interpret. They might be having difficulties to be credible, basically. So where does this take us? This takes us to a reality where there is a lot of data, but it's disconnected, that is hard to compare across borders, across sectors, across organizations, and on top it's actually costly to integrate. Now, fragmentation, is today's reality, but it's not a law of nature. It's actually a governance choice. It happens when every system, project, or country uses its own definitions, its own formats, and its own rules. So reducing fragmentation means that definitely we converge on ways of doing something, on ways of defining something, so that we can increase interoperability, and that's actually where international standards play a very important role. The Global Environmental Data Strategy talks about a very, very specific goal: a trusted, inclusive, accessible, and interoperable environmental data ecosystem. So interoperability is really this hinge that connects everything we are discussing today: environmental governance, efficient policies, and responsible use of AI. So what does interoperability mean? It means, in simple terms, interoperability means that the data from different systems can be found, read, understood, and reused together without having to reinvent a custom solution every time two actors try to connect. And why does this matter? Well, it matters for environmental governance. Why? Because with interoperability, we can make sure that decisions are increasingly dependent on a combined number of information. Like, it helps us having more information, a wider look of the different issues that may impact that decision. And if those data streams cannot be brought together in a reliable way, so governance will remain siloed. It's important also for policy efficiency because interoperability translates into saving time and saving money. With interoperability, the different teams that support policy development and implementation can make sure that the resources are used in an efficient way. And then it's also important for AI and digital tools because interoperability is what allows models and platforms to work with multiple sources of data and in a way that is traceable and auditable. So going back to my initial point, if we want environmental data to support coherent governance, efficient policy, and trustworthy AI, interoperability cannot be an afterthought. It has to be treated at the core of the design principle of our data ecosystem. So not just technical, but also in terms of the concepts, institutions, and the rule. So interoperability, we know it's the what. What do we want to make sure that data is coherent and that the environmental governance advances in our environmental goals? Now the question is, how do we get there? So again, here the response is international standards because they support technical interoperability in terms of format interfaces, application program interfaces, and protocols, and that's reducing fragmentation in a very practical way. Standards also ensure semantic interoperability, that we all agree on definitions, on units, on codes, on classifications, on metadata. So this means that data can be comparable across borders and across sectors. And thirdly, international standards can help with governance interoperability because they provide processes or standards ways of going through processes and responsibilities for data quality, documentation, access, security, and the lifecycle management of data. So that's what ISO as a multi-stakeholder platform bringing all key actors around the table can offer by developing the international standards that decrease fragmentation and support the interoperability challenge. Let me show you a very quick example on how we are actually doing that. And as I said, we have a portfolio of more than 25,000 standards. So the first step is actually navigating that landscape. So reducing fragmentation starts by understanding what is out there in the market. So ISO, together with our member in Australia, Standard Australia, and in support of the UNEP Global Environmental Data Strategy, has mapped our portfolio of standards, the more than 25,000 standards that we have, relevant to environmental data. This mapping is available through an interactive dashboard, and it provides an overview of the more than 1,000 ISO standards that can support environmental data. We have also mapped a number of standards that are referenced in our standards. So already by referencing other standards, this is another way of supporting interoperability. We explain through our standards how other standards might be relevant or connected. And it helps us also understand a little bit where the gaps are. So today, most of our standards are related to nature systems, but also geographical information and geomatics, but a bit less on other areas. Although we do have standards that cover the full data lifecycle. There is a dashboard that is available. The platform is accessible to anyone. Here, just a quick look on that platform. What you will see accessing the link that is on the screen. As you see, there is a possibility of searching by category or the full list. Here, an example of a list that of standards that are related to data and AI. So to conclude, how can ISO support interoperability and the implementation of the global environmental data strategy? We have, as I mentioned, a vast network of national standards body. There is one in each of your countries that is well connected to the ministries of environment and to other ministries, to the civil society that is well connected to the private sector and can support the governments and other parties identify those standards that are more relevant. We can also support, of course, UN agencies and intergovernmental processes to build new platforms, observatories, and AI initiatives based on those standards. And we can, of course, as well, through our standards, support scientists, data providers, civil society, and private sector in adopting interoperable standards in their project. So to conclude, what is my message for you today? My message is that aligned international data standards are part of the governance infrastructure we need for the environmental crisis. They strengthen environmental governance by making evidence comparable and accountable. They improve policy efficiency by avoiding duplication and confusion. And they give AI a solid interoperable data foundation so that can be deployed responsibly and effectively for the planet. So ISO, as a multi-stakeholder international standards platform, we stand ready to work with all of you to make that happen. Thank you very much.
For ISO standards from Australia and your team for this meeting work. And with that, I will hand over to the next speaker, Simon Hudson from Codata. Codata knows a lot about Simon. Okay, we need to admit first. But it was great that you could hear Naila very well this time, so hopefully the same will happen with Simon. Simon, can you hear us?
Hi, yes, I can. I had to leave and come back because all of a sudden I lost audio, but I think that might have been a Teams problem. Can you hear me okay?
We can hear you very well, and apologies for that. But great thing is now we can hear you, and then over to you to share about your work. Thank you.
Okay, so I will share my presentation. Okay, hopefully you can see my title slide, and you can hear me fine. So I was asked to talk about CDIF, the cross-domain interoperability framework. And this came out of a suite of activities that Codata led called Making Data Work for Cross-Domain Grand Challenges. And I'll explain a little bit about that. CODATA is the Committee on Data of the International Science Council. We're not just a committee, we're a membership organization that convenes and leverages an expert community around the world. And we have an expert secretariat that leads a lot of our work on various projects and on this sort of initiative. I really enjoyed Noémie's, I think, presentation, and in particular, the insistence and the emphasis and the definitions of interoperability. And that's really helped me a great deal because I think this is a good follow-on from that, because we've been working, if you like, at the coalface with scientific communities on how we enable that interoperability in various dimensions, in particular semantic and technical interoperability, but also to some extent legal and organizational interoperability. We were asked by the International Science Council to develop a program which we dubbed Making Data Work. The premise of the program was that all the major international grand challenges of our age, whether that's climate security, whether that's the growth of cities, whether that's the maintenance of biodiversity, etc., all of these can only be addressed through policy action that makes changes, informed by science that cuts across traditional disciplines. And to do that science, we need data that cuts across traditional disciplines, and we need to combine data across disciplines and across domains. So we've exploring a number of issues, addressing some of the challenges that were mentioned on semantics, on metadata, etc. We were very lucky to get a European Commission-funded project, which we called World Fair, which really advanced that work. And one of the key outputs of that was the cross-domain interoperability framework. And we're now pursuing an activity of implementation of the CDIF, of the cross-domain interoperability framework, in a whole suite of projects, because CDIF has attracted a lot of attention, and we've been able to raise quite a lot of funding and quite a lot of project opportunities to implement, test, refine, and extend the recommendations in CDIF. This slide tries to communicate one of our fundamental principles and approaches. This report, which I had the honor to chair, tried to set a roadmap for the European research area on how we would implement the FAIR principles, the principles that argue that data produced by research should be findable, accessible, interoperable, and reusable. And it is the case that since the FAIR principles were published, they've had a significant influence, and a lot of activity has sought to implement them, but less successfully, I think everyone would agree, in terms of interoperability and reuse. And interoperability is really challenging. We developed and presented this idea of an interoperability framework, which is a whole set of recommendations and guides and on how we achieve better interoperability. But a lot of this for research communities puts an onus and a responsibility on those communities. Research communities need to be supported to develop interoperability frameworks that define their practices for data sharing, their data formats, metadata standards, tools, and infrastructure. But above all, and this is why it's in bold, to support interdisciplinary research for those major challenges, like the challenges of environmental security. These interoperability frameworks should be articulated in common ways and adopt global standards where relevant and possible. And we would argue that that is relevant and possible in almost all circumstances. So here are the a slide with a lot of information about the outputs from World Fair. I commend those outputs to you. We worked with 11 case studies in a whole range of different disciplines to understand their challenges, the challenges of those communities, and the challenges in particular of interoperability and how they would make their data fair. There's a lot of reporting there, but the two main outputs were a set of policy recommendations where we urged a shift from a bibliographic to an engineering approach to data stewardship. And what we mean by that is, for interoperability, for the reuse of data, it is simply not enough to take a data set and put it in a repository as if it were a virtual digital book with a little bit of discovery metadata and think that our job is done. We need a data engineering approach. We need to think about those things that have already been mentioned by the previous speaker. What's the variable definition? What are the semantics and the terminologies associated with that? How can we make it easier for reusers of data to break apart the data set and recombine it? And our primary motivation and primary use case is data aggregation, so combining lots of data of a similar sort, or data integration, where for interdisciplinary research, we need to combine data from many different sources. Often that's according to time and space, but it could be according to specific variables. And the CDIF, the cross-domain interoperability framework, provides a guide on how to do that. So what is the CDIF? We started by identifying a set of functional requirements for interoperability, and in particular for data integration or data recombination. It draws on a lot of good practice that we observed from our case studies and outside those case studies internationally, and some of that those international initiatives where we felt there was a good practice are listed there. It is categorically not a new standard. We're not falling into that trap of the XKCD cartoon where we develop another standard. Really, the objective is to identify those functional requirements, to point to good practice, and then provide detailed guidance on how to implement. And the recommendations we make, the examples we give, provide a lingua franca, such that particular data standards or in particular semantics can be mapped to a CDIF expression of that, which improves the interoperability. So the current version of CDIF consists of 5 profiles as we describe it. Each of those profiles consists of a set of recommendations, a set of worked examples, and really concrete guidance on how to implement. We deal with discovery, so discovery metadata, a simple guide to providing more fine-grained access controls, and that's a work in progress to make that more applicable. A guidance on controlled vocabularies, data description for data integration, and universals, often time and space, but also units of measurement, how they're best expressed for interoperability and for combination of data sets. I'll spend a little bit of time on 2 slides now with something that's a little bit more technical, but hopefully this is intended to give you a flavor of the sort of recommendations and why we feel that CDIF is doing some very useful things and moving the needle a little bit in a way that's very practical and will help adopters. So the discovery profile has a content model, so we suggest a set of fields that are both either mandatory or recommended. We demonstrate how this can be serialized in JSON LD and using schema.org vocabularies. And we also do a mapping to DCAT, which is another widely used vocabulary for discovery. And we demonstrate workflows for publishing CDIF metadata there. This has been extremely well received. It aligned with a lot of emergent good practice in the Ocean Data Information System and in Science on Schema.org. But there's one recommendation, one very simple recommendation we think is really important, and as I said, moves the needle a little bit, which is use in the discovery metadata the definition, the description of the variables that appear in the data set. Let's not treat data like books. Let's allow our search engines and our AI tools to discover the variables that have been measured, the actual things that have been measured, not the values, but the phenomenon which have been observed or measured in whatever way. And this would greatly improve the discoverability and the interoperability of data sets. Related to that, in the integration profile, we use a standard and point to a standard called DDI-CDI, which was specifically designed in parallel to this work, and we've collaborated greatly with the Data Documentation Initiative, which was designed precisely for integration of data across different disciplines. And this was done in response to a call from many social science research archives who were increasingly having to combine social science data, social survey data, for example, with climate data to understand attitudes to climate change, for example. DDI-CDI provides, in particular, structural description of data sets, such that the structure of the data set can be understood by a machine and by a human, and it can be easily decomposed and recomposed. And above all, it has this thing called the variables cascade, which establishes a clear conceptual and semantic link between the concept, how the concept is described for the data, so the variable, what is being measured or observed, and then how it's implemented in the data set. And this is a really valuable tool for data integration. So we have a roadmap for C. diff, and the areas in green are indicated there. Those are the areas that we're working on at the moment. We're doing further work on context, provenance, and quality, doing further work on semantic mappings and examples of good practice in that, and further work, as I indicated, on extended access and further details on how we can control access in a fine-grained way. I mentioned at the outset that we have a set of projects where we're doing C. diff implementation, so implementing, testing, refining, and extending the C. diff recommendations. One of those is a large European Commission-funded project called Climate Adapt for EOS, for the European Open Science Cloud. And what this slide shows is a process that we're doing with the 3 case studies which we have in that project. One is on urban heat, one is on overtopping and coastal erosion, one is on the shrinking and swelling of clay soil. So all really important phenomena that are affected by climate change and how human society interfaces with that. We're taking this input data, we're mapping that to C. diff, enhancing the semantics and the metadata. We're undertaking data integration using the C. diff profile, in particular that integration profile and DDI, CDI, and then we're applying the metadata description to those data products. And each of these particular steps we feel can be better facilitated by that mapping to the cross-domain interoperability framework. Finally, we have another project which is with some support from the International Science Council and working with FIM, the Public Health Institute of Malawi, taking and integrating a whole load of data about the Malawi floods and the cholera outbreak which happened after those. And this is a really important demonstrator of those techniques for data integration. What's really interesting about this particular project as well is that we're piloting some work that a colleague of mine at CoData has done on developing an AI assistant that helps with metadata enhancement and semantic mapping. It provides suggested and recommended definitions for the variables. It provides recommended mappings for the semantics. And just this week, we've integrated that with a user interface, which is taken from the Nectar metadata publishing tool. And those suggestions from the AI assistant are surfaced in the Nectar publisher. And then the human in the loop can select the most effective and the most appropriate and validated definition which is presented. And we think this will be a real game changer for providing metadata and for enhancing data sets for interoperability and integration. The work has been well received internationally, and among other things, the Australian Research Data Commons have put in a proposal to implement C. diff and some of our policy recommendations in their Australian Planet Commons. And there, importantly, we'll be combining our interest in the FAIR principles, findable, accessible, interoperable, and reusable, implementing the C. diff, but also trying to understand how we can do that in a way that responds to and supports the CARE principles for Indigenous data sovereignty. And I think that's a really important aspect for how we deal with environmental and planetary data going forward. So this is my last slide. Current areas of C. diff development. This is a sort of a watch this space slide. We're improving the C. diff documentation. I provided on a previous slide a link to the book, but we're improving the documentation for developers, and that should be ready in April 2025. We've got a number of collaborations to improve the tooling and to implement CDIF metadata and the work that I mentioned on AI agents. We're extending the work on provenance, context, and quality, which is really important, and the other areas that are linked there. And above all, we're stressing the importance of variable description to move the variable as a first-class object. And I think that aligns with a lot of scientific and policy oriented activity to establish agreements around essential variables in various areas of research and that have important policy connections, like the essential ocean variables or the essential biodiversity variables. I think there's work on essential environmental variables, and I think these are really important. These are really important activities to assist interoperability, but also to address key policy objectives. As with the previous speaker, we're very keen to take all possible steps to build this work and the cross-domain interoperability framework into the GEDS framework. So thank you for your attention.
Thank you, Simon. CDIF was mentioned already at the GEDS as one of the best practices out there, both for interoperability within the environmental domain and interoperability between environment and other domains such as social, health, and etc. So for those of you who work with data closely, I invite you also to learn more about CDIF. And let me hand over. We have two more speakers and 27 minutes left, and I'd like to save some time for discussion. We have so many guests in the room. So please stick to 10 minutes. And the next speaker is Samai Joseph, Research Director of Stockholm Environmental Institute. Samai, over to you to share updates about your work.
Thanks. I hope you can hear me in the room. Is that all right? Yeah? Okay, then I'll try and share the slides the best I can. Hopefully you see that and hear me. Yeah. So the previous two speakers have covered, I think, the topic of interoperability and standards when it comes to data really well. And I'll try in my presentation not to repeat that, but to be really concise and go over what are some of the implications of that when we talk about sustainable AI futures. So when we just heard about interoperability, we talk a lot about limited transparency when it comes to data, methodologies, and these input choices really hamper our ability to look at or compare estimates when we talk about AI's energy, water, or critical mineral footprint, for example. Currently, we have several estimates, and we often find that they do not match, and this has a lot to do with where the starting points are. Furthermore, projections of AI's resource use are inseparable from the futures that their authors envision. So this is why it is absolutely key, as the previous speakers also underscored, that we have this shared vocabulary and this collective starting point. Now, this is based on a study that we look at together with Schneider Electric, where we did some scenarios for EU's AI electricity demand in Europe. 4 scenarios were looked at, looking at sustainable AI, limits to growth, abundance without boundaries, and of course a crisis scenario. And this is keeping in mind just the small example of Europe, where we looked at a pathway to 2030, and you see that trying to even estimate this with no clear standards or data that can speak a compelling narrative about what will be the projected use of electricity, and this is a very bounded case, that can then give you some idea on how you extrapolate when we talk about, let's say, the water footprint of AI, or how the current bottlenecks that we see in terms of critical minerals and the global supply chains look like. Furthermore, at SEI, we've developed a tool called Sapient and Policy Reader, which looks effectively at policy coherence. So the previous speaker touched upon the need for this application in the policy area. And this is precisely what we try to do here, to see in any given policy with regard to, let's say, sustainable AI, where are the synergies, the trade-offs? How can we understand the effectiveness of the said interventions? The kind of contexts we look at are deforestation, water, land use risks embedded in the supply chain of AI. We look at critical minerals. We look at how finance can then be effectively directed to where it is needed most in these contexts. So we have used AI in some of these tools, such as the Policy Reader and the Sapient tool, to really tease out from vast bodies of data and do an effective global stock take on where are the hotspots and the gaps. When we talk about policy effectiveness also, it's important to understand what works, where, how, and why. So you see also, as we go from policy coordination to policy coherence to policy integration, the importance of data underpinning that, the standards and the interoperability of that data becomes crucial if we want to understand what is effective, where, how, and why. Through our work, what becomes clear is what is a successful policy outcome. So we look at it also in terms of spillover effects. When in the policy cycle can we link to this outcome? So what's the coordination needed behind that, the integration, the interoperability? Where in the policy cycle should the agenda setting take place, and what patterns emerge in terms of the national socioeconomic development and global leadership context? What I wanted to show you here is how complex the value chain of AI is at the moment. If we break it down, this is from Cartography of AI, which I encourage all of you to look at because it really tries to connect the dots in an integrated way. Are we talking about the hardware that goes into the AI supply chain, from semiconductors and chips, the GPUs, to the electricity usage in the training and inference data stage, to the water and to the critical minerals? And when we put all these data sets together so that they do not exist in silos but actually talk to each other, and we're also able to see the effects. For example, what happens when we redirect renewable energy towards data centers that was being used to decarbonize grids? What is the backlash we face, or what are some of the counterintuitive areas in this picture? Then we get a more systematic look of where we can intervene and have the most impact. And I think this is my last slide, where I wanted to really underscore the importance of how, when we talk about sustainability in AI, there is this invisibility of data, infrastructure, ecosystems, and labor that goes behind it. And the previous picture that I showed about the whole supply chain, how it looks when you break it down, what is important is to make this more visible. And I think the previous speakers also touched upon this, that through these standards, through this massive effort, which is by no means easy, to have interoperability, we make these each of these pillars more visible and truly understand the nature of what we're up against and how we can make this process more sustainable. So I'll stop there, but really happy to take more questions later when we have our Q&A.
Thank you, Samaya, and thank you for reiterating the point how important interoperability is. And even though it sounds like a technical term, and even when we started research on big data, I think that one was most abstract out of all other issues we're tackling. I think this is one of the key ones that needs to be addressed in order for environmental data ecosystem to work properly. So now we are moving to the last list speaker, Hélène Costa from Ministry of Ecological Transition and Territorial Cohesion in France. We will share about their work on sustainable AI, and France is one of the colleagues of the Sustainable AI Coalition, together with ITU and UNEP. So, Helen, over to you. Thank you.
Thank you so much, Paulina. Hello, everyone. So building on the insight shared by my other colleagues on this panel, I would like to offer a complementary perspective focusing on the policy approach to sustainable AI that we have in France, and which is actually two-pronged. We are both working on how to leverage AI for our ecological transition and environmental goals, and how we also work on the environmental footprint of AI. So actually, France designed its sustainable AI policy in a very practical and grounded approach, started in 2022 with our second national AI strategy, whose goal was to disseminate AI within the economy. The first one was really more focusing on research. So from my ministry perspective at the time in 2021 to 2022, this means leveraging AI to decarbonize, adapt, and preserve. So basically, we were already using AI for the environment for a long time, and it was done at our environmental technical agency level, such as the other institutes for forest and mapping, or with our weather forecast agency. And as I said, they were long using AI in their models and tool, and now they are accelerating the use of AI and piloting new use of AI since the breakthrough of deep learning and foundational models. Simultaneously, we recognize the need to test AI application in addressing real-world environmental challenge. And this insight prompted us to establish a 40 million euros initiative really dedicated to funding localized pilot projects that harness AI for the ecological transition. So far, we've selected 12 projects spanning domains such as biodiversity monitoring, human planning optimization, and building energy efficiency or water resource management. All of those were really grounded on AI, using mostly quality data based on physical measurements. Like none of them were using Gen AI. The early results are not demonstrating tangible outcomes. So only one example in Noisy-le-Grand, which is a medium-sized city of about 70,000 inhabitants, the energy efficiency program for public building that they developed using AI allowed them to achieve, after only 18 months, 20% of energy reduction and 2.2 million in saving. So this is really the kind of purpose-driven, tangible, and at the local level AI that we would like to support and disseminate further. So building on this success, additional programs are also being launched to support new pilots to keep exploring how AI can support our environmental transition. For instance, we've integrated AI for adaptation into our National Climate Adaptation Plan, and we have also launched a dedicated program to support startups and SMEs developing cutting-edge AI for environmental breakthrough. Looking ahead to 2026, our priority is sharing lessons from both successful and failed pilot and supporting duplication of successful pilots. So to support this disseminating effort, we have launched targeted tools and initiatives, including the data portal ecology.data.gov.fr, which enables entities to share use cases online alongside the associated methodologies and the data set that they use within this program. And some of them are using AI. We launched a partnership with cities and local governments to start an online repository of AI pilot projects implemented at the local level. Other local entities to duplicate the pilot that have been successful and it was launched. So that was like the first aspect of our AI sustainable AI strategy. But that being said, using AI, as we saw previously, always is not neutral. it always has an environmental footprint, and with generative AI, the footprint is really becoming to be massive. So environmental AI and greener AI is really the second pillar of our sustainable AI policy. France has been at the forefront of ensuring that the digital revolution before AI and the environmental transition go hand in hand. And as early as 2021, we actually enacted a law on reducing the environmental footprint of the digital sector. That's why when we started to experiment with AI, we start from the to ask ourselves, how do we prevent AI environmental footprint for undermining and cancelling out the sustainability gains of the solution it enables? At the time, there was no methodology existing addressing the environmental impact of AI models. So that gap led us to create the Frugal AI framework, which was developed collaboratively by the Ministry of Environment and the Ecolab, which is the directorate where I work, and AFNOR, which is our national ISO agency. And we work with the whole ecosystem, with the spanning major technology companies, startup, and academic institutions. This global framework, framework was published in 2024, and that was a global first. The framework delivers practical, actionable guidance. It provides a standardized methodology to measure the carbon, water, and resource consumption of AI systems. So I'm really talking about like the AI system and the models, along with concrete best practice to minimize environmental impact. This includes really practical steps, such as first asking when you start a project, is AI generally necessary to solve this problem? Which AI model best fits our needs? Most of the time when we're talking about environmental projects, you might not need to use generative AI. And if you need to use generative AI, you're probably best with using a small language model or a compressed version of the current LLM. And then we also have within this guide best practice that will walk you through how to concretely reduce the environmental footprint of the AI system you choose, such as if you need to train your model, do so with high quality data sets, ensure that the model is on servers that are powered by decarbonized electricity and so on. Now we are actively promoting this guideline to make sure that there is a more efficient use of AI across the stakeholder ecosystem. And in 2026, we are working on two parallel initiatives. The first one is really to engage the private sector through the Sustainable AI Toolkit, which is a kind of like shorter version of the AI Frugal framework. And secondly, we are leveraging the public procurement and launching like a dedicated guide for responsible purchase, public purchase of AI solutions that published in a few days. And both of them are grounded in the Frugal AI framework. So that's for what we do, really in a nutshell at the national level. However, when we talk about the profound transformation of that AI is bringing, we also need to bring the perspective at the international level. So that's why, like 10 months ago, France had the honor of welcoming the AI Action Summit in Paris. And within this summit, we wanted to focus on the potential of AI for good and draw a link between AI and the environment alongside inclusiveness, ethics, and safety of AI. So during this, the Paris Summit, we co-initiated with UNEP and ITU, the Sustainable AI Coalition, which was launched with 90 founding members and the support of like 14 countries. It's a community like now, 10 months later, we're over 200 members. It's really like a community that gather together manufacturers, AI providers, clients, researcher, investor, NGOs, like the whole ecosystem of AI and of users of AI. So the coalition, what is the coalition doing? So the coalition addresses both dimensions of sustainable AI, like green AI, the environmental footprint of AI, and how do we best leverage AI to reach our environmental goal. And the way it works is based on three observations that we made. So the first one is a robust AI governance framework is already in the making, and so we really do not need another redundant oversight structure. So the coalition is really not a new governance framework. The coalition instead prioritizes information sharing, soft coordination, and exchange and harmonization of best practice among existing among member and existing initiatives. Second, the global dialogue on AI was really focusing on safety and ethics, and so it remains to us incomplete. And so that's why we thought it should be expanded to encompass AI sustainability, just because this is a critical imperative given that AI resource demands create systemic pressure on national infrastructure and ecosystem, and we really thought that this voice needed to be carried strongly. And third, the discussion on digitalization and sustainability currently occurs in various forums, and the coalition addresses fragmentation by ensuring a consistent flow of information across those disconnected conversation. So hence the coalition functions as a catalyst, an amplifier, and an incubator of initiatives advancing these priorities. Its approach really centers on active members' engagement, and the coalition will support the action of this member through three distinct initiatives. The first one is the Initiative Hub. So it's a comprehensive platform providing visibility into international collaborative efforts on sustainable AI, enabling members to navigate the complex landscape of relevant forums and identify opportunities for participation and alignments. As we were talking about standards, I wanted to highlight one of those initiatives, which was launched at the Paris Summit, which is the roadmap for the standardization of the measurement of the measurement of AI, and it will give you like an overview of all the work currently undertaken by ISO, ITU, IEEE on the subject. Second, the coalition is really active on communication and making the topic visible. So we always have try to have active engagement at major international conference to elevate sustainable AI's profile and foster cross-stakeholder dialogue. Finally, we also foster action with a strategic launch of focus workstream aligned with key international conferences and milestones. And we will be also launching in 2026 a dedicated AI research pitch session designated to catalyze funding, forge partnership, and accelerate the dissemination of sustainable AI research. So the coalition is open to new members from the private sector, from NGOs, from research entities, and countries would like to support these endeavors. Though there's no financial or legal contribution required. I just wanted to make that clear. And I think my time is up. So thank you so much for bearing with me. And I'm looking forward to any question you might have.
We have only 5 minutes left for this event, and I will use it for the questions that you might have to any of the speakers. Thanks again for joining us today in person.
Hi, my name is Nina. I work with UNEP here at Dublin City, the World Conservation Monitoring Centre at my university. So we have a lot of data standards, and we're very mindful about the Sarah care principles. And I just wanted to reflect on the fact that I don't remember which speaker, but I think one of you almost agreed in another together how AI can harmonize some of these different data standards. We have hundreds of standards, even in the biodiversity field itself, there are plenty, and it's very, very overwhelming and confusing. So I think AI can really help with the discovery of and interoperability of the data standards. And you mentioned the use of fair and care, but even within these fair and care principles, there's variation. So how can we actually use AI to identify those gaps within the fair and care principles in order to strengthen the implementation of fair and care principles as a whole, rather than just saying, we follow fair and care principles, but we know there are lots and lots of variables within that we don't really follow. So it was a bit of a reflection. Thank you to all the speakers.
So thank you, Ian. Thank you for your question and your reflection. Are there any?
I mean, if you'd like me to, I caught the sound broke up a little bit, but I think I caught enough to respond, and I wasn't entirely sure to which speaker that was directed, but it mentioned the fair and care principles, and so I can respond to that if you'd like me to. Certainly the work that we're doing at CoData and with the CDIF, with the cross-domain interoperability framework, is very operational. And in the sense of using the AI assistant that I mentioned in the Malawi project and elsewhere, that is exploratory work. It's quite experimental at the moment, but we are extremely excited by the results that we're getting and how useful that is likely to be. And we certainly hope with a little bit of, with a lot of further development, that can really be a game changer in terms of providing the rich metadata that the FAIR principles allude to. The sort of things that can do is providing mappings between terms. So that can really assist in the interoperability and the integration of data sets. And that's extremely exciting. We do need to be humble, and we need to make sure that all this is extremely well documented, that the AI assistant is trained as much as we can, and we're using a model context protocol to make sure that the source of the definition is communicated as much as possible, and sometimes that's challenging, but we can say that these definitions or these mappings are as authoritative as possible. You also mentioned the care principles, and certainly in the work that we hope will go forward with the Australian Research Data Commons, there the issue is how we attach metadata to data to ensure the respect of many rights, online digital rights, privacy rights, and those that are articulated in the care principles. So the work that we've started there is looking at the Open Digital Rights Language, which is a W3C standard. And again, we're pointing to international well-adopted standards, the data privacy vocabulary, and an ontology that was produced in the public health space called DUA, the data use ontology, which has a lot of very useful terms for describing how data may be used. Our current assessment of the situation is that with some extension, that cluster of three standards, plus additional concepts, can help us with the fine-grained management of who has access to what data and can use it under what conditions and what obligations. And then you can see that can be, in partnership with the communities involved, adapted to the requirements of the care principles, so that we can try and ensure that when data is used with permission, according to certain criteria that might be laid down by the communities in question, that the obligations of involvement, of review, of participation, of respect are undertaken. And we can track that through the provenance chain as of the data and the research. So that's the objective. That is all easier said than done, both technically and in terms of the work that needs to be done with communities, with researchers, with metadata architects. But I think we have a clear path for how that can be very usefully implemented. I hope that answered the question.
I'm afraid our time is up. We have more questions. But I don't want to keep people in the room. We will address those questions, but if you want to leave, you can leave. But for those who would like to continue, please stay longer.
Hi, my name is Mr. Marsman. I work for the Financial Market Institute. I want to respond to the question of how we can do with environment during metadata, and we can go about one solution is to look to novel methods that can be standardized, and where in passing, if you standardize the procedure of the method of data collection, you are also acquiring the data and metadata in fair way. This, of course, needs to be then done inclusively so that the standards are developed with the user community, so engaged in standardizing DNA approaches internationally, reporting monitoring, ISO, and we do that via also another platform where we try to engage with individual scientists, not so much standardizing bodies, so that really the community has the possibility to engage in that. So the novel methods, it's much more easy to go towards that road. It's much more difficult for the normalization of methods. Thanks.
Thank you for the reflection. And one more question.
Thank you. Good evening. I just wanted to ask, I also want to say I don't know a lot about how data works, but I understand the research in AI. For example, I'm from the arid lands Kenya, so we use the AI one system. That's really good. But the bad news is I'm really concerned with the water usage of AI. As you are aware, AI uses a lot of water, and I think that's a major concern around the world. During emissions that use nature, we have to be really mindful on how we can ensure there's no usage dependence on water for data purpose. So also my other question will be on the sustainable AI commission. In this commission that we have countries there and companies. So my concern is this is a field that's highly for profit, and we really have to have people watching care of nature. Do we have some individual stability there that have interest to protect the earth and the planet? So really good to have those there. Thank you.
Thank you for your questions. And then would you like to take this one on sustainable AI commission board? Oh, yeah, okay. We have, you can come in next into the next, and then we can take this question.
I just want to make a comment to your last question, and I will leave Helen to speak about the Sustainable AI Coalition, but we have members as well. The government are tested by the people. You are voting the government. They should be the ones, balancing the interest of the industries. And on the other hand, this is a political game, what you say. And on the other hand, we need to be ambitious. We need to be ambitious to develop, because the colleagues and other speakers gave an answer on how we can use AI. We can use AI in many ways, helping our lives for sure. Okay.
Thank you, Helen. Would you like to comment on the Sustainable AI Coalition and the members, their representation? Or you couldn't, Helen, can you hear me?
Yes. But I couldn't hear the questions properly. So I'm really sorry because the sound on our hand is really choppy. So I'm happy to comment or to give anyone insight, but I don't know the question. I cannot hear. I think the sound has been cut on our hand.
Can you hear me now?
So sorry, we cannot.
Okay.
Yes.
Or you do. So we try it one more time now. Yeah, it's good. If you could type. Can you hear me now? Let me try it for a bit one more time.
It's really choppy. It's really hard to hear.
Or if folks could type the question on the chat. If you could maybe answer the question on the chat about the membership on Sustainable AI Coalition. Or we can take one more question and then come back to this one. One more. My name is Sarita Lumiere, and I am completing learning. So this whole conversation about assistive AI, sustainability, with regards to the standards that usually continuously being worked on and refined by ITU, ISO, and other organizations. I mean, you're doing amazing work. But then something I'm curious about is with regards to the implementation. So it is, at the end of it all, you have the standards and you've done a really good job. So so when it comes to the implementation of the standards, is it something that will be voluntarily taken in by AI companies, or will it be mandatory? A mandatory requirement when somebody starts through the standards involving it or whether international or national or otherwise. But with this, everything that we've discussed, it's love to know how it will be implemented in real life. So, yeah, thank you.
I will answer very short because we have time more. Okay, all the standards are recommendations. They are in by the industry. They are not mandatory. If we want to have mandatory standards, and mandatory for all the countries, but they are subject of a treaty. And treaty is implemented in the national law. For the governance of the idea, multi-stakeholders, there is no one party is responsible for that. You know that the UN Secretary General started, and next year will be the first dialogue on AI governance, and it will be in Geneva in July, back to back with AI for Good Summit, where they will discuss these aspects. You know, there were in the history what I know for my area of responsibility. It was at one point almost done treaty on cybersecurity, but at the end it was not really, approved finally, and that's why they are just recommendations. Just the industry is taking considered seriously, but the operability is a good incentive for that because if they save money, probably they will take the standard.
Thank you, Catalina, for your answer. And then I think we have the question in the chat now. Maybe you can come in. And,
yes, thank you so much. So the membership is really open, and it's open to any kind of organization. So obviously it's open to indigenous people representatives. We have like two kind of memberships, what we call like the members, which are really like the corporation, the SME, the startups that are part of the value chain, and the broader AI ecosystem, including like the research, academics, investors, and NGOs and associations, because it's really important also to have those voice within the discussion to ensure that the environmental footprint of AI stays core to what the coalition is defending. And then we have another type of members, which we call the supporters, which are for international organizations and for governments. Which are supporting the coalition, and so I think that if a representative of indigenous people would be interested in participating to the coalition, you just send us an email, and then we could discuss in which category the members wants to be added.
Thank you, Roland. Are there any more questions? Thank you, Mrs. Din. Thank you for participating. And we will have one more opportunity to cover and discuss this topic in a week. On next Wednesday, there is a guest breakfast. So we will focus again on the topic of interoperability. One can discuss it again and again and again. So we will dive into that, and also we'll look at the environmental impact of AI, because it's connected topics. So there is a QR code there on the slide. If you would like to register and join the breakfast, it will be more high level with ministers from different member states attending as well. We would like to hear more from them and their perspective. Please register so that you can join us next week. Thank you so much, and have a nice day.
Thank you.
Everything goes wrong. Happens today. I feel so happy. Will you ask me